So this is a nice and convenient now. We have a square and square root function, and that allows us to go from a area to side length. So if I have this area here, and I really want to find the edge length of this square. So I can just look at it and count. It looks like it's 5, but I can also do it this way. I can find 25 squares here, and then square root, and get the edge length of 5. Okay, and then same thing here. I can really just count across 1, 2, 3, 4, 5, 6, 7. So, and I can count 49 squares in here, and I get an edge length of 7. Okay, 7 units. The diagonal squares are a little bit harder to find the edge lengths, but now we have this strategy. We can chop this up into right triangles, okay, by just following the grid lines. And by following the grid lines, we can easily calculate these areas because we have these nice shapes. We can count the 4 squares in here, and we know this is a 1, 2, 3, 4, 5, 6, 7 by 5 triangle. So if I have a right triangle, length times width, okay, as long as it's 90 degrees here, length times width divided by 2 will work. So 7 times 5 divided by 2 is 17.5 of area here. And the nice thing about this shape is that it's all symmetrical, so we know that those are all 17.5. So I can get the total area. So my total area is equal to 35 plus 35. It's equal to 74 units squared. Okay, and then the edge length, this is what I really want, is the edge length. It's exactly 70 square root 74. You remember square rooting gives me edge length. If I actually work out the decimal, and I actually prefer the square root 74 as an exact value. But if I do want to know the decimal, approximately how long is it, it works out to be 8.60. Okay? And then I can do the same thing for this one. These squares look pretty much the same size. So maybe it's the exact same length. Let's try it out. Okay, so we're going to draw our corners in. Okay, so we're going to draw it in like that. I've got a 4 by 4 square in the middle. This is 4 by 8. So it's going to be 4 times 8 divided by 2. 4 times 8 divided. These are all 16. Okay, so that right triangle is really useful because it helps us, and I can even draw it out on the outside here, this right triangle. You notice that right triangle shows up on the outside here too. Okay, but the total area here works out to be 16 by, so it's going to be total area equals 80 squares. Okay, and so the edge length of this works out to be the square root of 80, which is just, this square is just slightly bigger. It's slightly bigger than that one, and it works out to the square root of 80, which is approximately square root 80, and that gives me almost 9, so it's about 8.94. And these two squares look fairly similar in size. Well, this one's got 74 squares and this one's got 80 squares. So our edge length works out to be about the same. Okay, so this is 8.94 units from 80 squares, and this is 8.60 units from 74 squares. So how do we find the side lengths of the diagonal squares? Well, we broke this up into a square and into one square and 4 right triangles. And added up the areas. Okay, and then we found the side length from the square rooting the area. Okay, so that's the first part. With the second part is we took the square root of area to get side length. Okay, and that finds the length of those diagonal squares, which would really have been quite hard if we had to measure, because it's not a very nice length to measure out, because it's not a whole number length.